know where we started? You know the topic we started this term? If you don't know, that means you are new. So let me guide you. Within 5 minutes, we'll move up. We arranged JAMB syllabus. Please concentrate. From chapter 1 to what? 11. 12 to 19. 20 to 28. And all that. Down to 39. We have 39 chapters of the JAMB syllabus. I have a hand copy. It's here. I'll hand over. So that if you want to photocopy, please leave the issue of soft copy because I know on the phone. If you have your syllabus inside the phone, you'll be tempted to go into other things. Please leave that alone. Go into, look, JAMB is how many months? That's exactly the question you ask yourself. Don't allow those peons inside the phone to deceive you. I mean, be a serious candidate. So now, I came back again down to the beginning of the syllabus because somebody is already working from 29 and above. And myself working from 1 down to 30. That's to 30 something. It's likely I will stop at 30. But I started from 1 last year. Chapter 1 to chapter 11, makeup, mechanics. Mechanics. Those of you that are new, not new to physics, but here. In your syllabus, mechanics covered from measurement as question, as topic number 1. You have measurement as 1. Number 2, you have scalars and vectors. 3, you have motion up to density. If you list them, work, power, and energy, machines, all that, equilibrium of forces, elasticity, it will land you at where? Density and upthrust. So the whole of chapter 1 to 11, mechanics. If you have not gone through the mechanics, we're already through with that here. Please, create time. Go through it because you see more questions from mechanics, from waves, and from electricity in your forthcoming exam. More questions. More questions. Never ignore anyone at all. Mechanics, without mechanics, there's no physics. So don't just ignore that first part. Okay, it's SS1, SS2. That's the measure. That's the measure part. Go back to them. Go through all of them. Get real informations. Please. For this center, we're already through with that. We moved over to 12 to 19. And 12 to 19 is heat. This is mechanics. This is heat. Here is waves. Then, as you proceed from 29, you see electricity and all that. So we have these branches of physics. The way JAMB listed it, that's the way. Now, I am now in this area 12 to 19. I came in here and asked you to choose between this and this, between the 3. And the majority said first topic here. And right inside here, we're already through with chapter 12. Now we're going into 13. Chapter 12, I gave you assignment. And that assignment, next class I'll present, because more people are here. Next class I'll present 2 questions. 1, on the advantages of expansion. 2, disadvantages. Sorry, 5 questions. I have them already. Then 3, applications. And somebody gave us those examples. So please, still go back. My next class, I'll present the questions among the girls and the boys. And we know the good readers. Okay, let's go straight because of our time into chapter 13. And what is chapter 13? What is chapter 13? Temperatures. Chapter 13, temperatures. This is a common topic in physics, but you see this topic everywhere, every year, in every exam, from time to time. We're going to summarize this and go into chapter 14, because this is not too much like the last one. Okay. Somebody gave us a question based on the last, on volume. Do we solve the question? Okay, now write down the question. Just help her solve this question, please. After this, anytime, if you have question, bring it to me after on the last topics, because we're already through with those topics. Now write down this question. A rectangular metal block. A rectangular metal block. We want to help the owner of this. A rectangular metal block of volume 10 raised to power minus 6 meter cube at 273 Kelvin. At 273 Kelvin is heated to 573 Kelvin. Full stop. 573 Kelvin. Full stop. Please, let's help the owner. If its coefficient of linear expansion, is 1.2 times 10 to power minus 5 per Kelvin, comma, determine the percentage change of its volume. Percentage change of its volume. Percentage change of its volume. Full stop. I repeat. A rectangular metal block of volume 10 raised to power minus 6 meter cube at 273 Kelvin is heated to 573 Kelvin. Full stop. If its coefficient of linear expansion is 1.2 times 10 raised to power minus 5 per Kelvin, determine the percentage change of its volume. Thank you. Please help the owner of this. That's the only one we can solve for now, because we need to move. During revision classes, we can go back to all this, because after 2 weeks, we do kind of revision. Help the owner immediately. I'm waiting for the results. Yes? Anybody? Much time. Jamb is 40 seconds per question. 40 seconds. Not up to 1 minute. Anybody? Okay. I got your calculator that day in exam. Huh? Still waiting for the fast students. Those fast ones. Hmm? So long a letter beg. Yes? Anybody? Try. Time munka karizra kario. Even with a big calculator. Huh? Okay. Please, let's stop here. That was an information I gave you. Those of you that started on the base of this topic, I told you how to get the change in volume, change in area, change in what? In length. So the first thing you're supposed to do is to get the change. And how do you get change? You say variation or change. Change in volume will be what? 3 what? 3 what? 3 alpha what? V1 change in what? Theta. That is the change in volume. This is the value I gave you. Change, hence you hear variation in volume, variation in area, variation in this. You bring in that variation. I told you that is what you use at all time to get the change. And how will I use this? 3 times alpha is 1.2 times 10 to power minus 5. What is the initial volume? 10 raised to power minus 6. Am I right? And what is the change in temperature? 100, because you are not, I told you, don't change anything. Some of you started changing back this. No. If it's in degree, go with degree, because what you have as the linear is per Kelvin. If it's degree, go with it. If it's Kelvin, go with it. Because temperature remains temperature, but this is where you have the variation. So this one, 573 minus 273 will give you what? 300. Thank you. So here is 300. Now, I taught you how to work on it. I said, this time this is what? 3.6. 3.6 times 300 is what? 1000. 1080. 1080. This is minus this is what? So this is minus 11. So we can count this to 1, 2, 3 to make this what? Minus what? Minus what? Minus 8. Minus 8. We can count 1, 2, 3. To cancel this now to make it remove 3 from here now. Yeah, plus 3 means minus what? Minus 8, okay? So I can write 1.08 times 10 to power minus 8, which is meter cubed. This is the change in volume. And we now lift this change in volume. They said percentage. They said what? Percentage. If I want to get the final volume is V2 equals what? V1 plus what? Change in volume. That's what I taught you. If you add this formula now, if you add V1 plus, it will become V2. Okay? Up here, Kaime. This is exactly. But when you remove this and this, it will be change in volume. So you add here, this value now, if you add V1 to it now, it will be what? It will be final volume. Final what? Final volume. So assuming you're asked to get the final volume, it just V1 is 10 raised to power minus 6 plus what? Plus 1.08 times 10 to power what? Minus 8 to get the final volume. Remember how remember how we added. I taught you how to add this on Monday. Am I right? So how do we add? You count number of what? Number of zeros. Just simply add number of zeros. First one is how many zeros? 0.1234. That's 6. And what again? 1. Next one is what? 8 zeros, okay? 1, 2, 3, 4, 5, 6, 7, 8. And what is it? 108. So adding this now, we give you what? 8, 0, 1. Is that 1, 0? This is, okay, 0 what? 1, 0, 0, 0, 0, point what? And I said 1 point what? 0, 1, 0, 8. If you want to go with them, times 10 raised to power what? Minus 6. Minus 6. So if you add these two together, this is what you obtain. And when you obtain this, you bring it as a final. 1.0108 times 10 to power minus 6, which is per Kelvin. This is your final. But they said percentage what? Percentage what? And how do you get percentage? Change. Change in volume over what? Over what? Over initial volume. Times what? 100. Times 100 over 1. Now, what is the change in volume? 1.08. 1.08 times 10 to power what? Minus 6. Over what? This is the change in volume. Over what? That is 1 times 10 raised to power minus 6. Multiply by what? 100 over 1. This. It's a 10 raised to power minus. Okay, 10 raised to power minus 8. Minus 8. That's the change. Thank you. Now, from here, this divided by 1 will give you 1.08. But this can divide this to give us what? 10 raised to power minus what? 10 raised to power minus 2. Now, 10 raised to power minus 2. Remove this. What is remaining? use it to multiply this. Like I have here, times 10 to power minus 2, okay? Multiply by 100. And 100 is 1 times 10 to power what? To power 2. So this and this will go. So what is remaining? 1.08. 1.08 what? Percent. So this is what we're looking for. You know, I took time to explain this back one by one. I took time to go through it again. Meaning that for us to go through this, it's just long process. Now, during revision, I will use quick means. I don't want to start using those short means now. I'll use very short means for revision, because by that time, you're already used to all these formulas. Because up to now, some are still looking for, hey, variation in this, variation in length, area, volume, and all that. But I explained all these things. I told you, please, take them down, go through them. Hence, they ask you anything concerning final, get the variation, add it to initial, and you go on. You go direct. You go direct. Okay, so let's go back to temperatures. Temperatures. Please suspend every other question concerning the last topic so that we finish up. We're supposed to finish this topic, temperatures, and move to the next one, which is chapter 14. And chapter 14 is, I think, gas laws. Are we ready now? Let's move directly to the topic called temperatures. That is chapter 13. You can't use short method in solving jam questions unless you know unless you know the normal method. Like this normal method, you must know your formula. You must know how to get the variation, how to get the final using initial and the coefficient of expansion, which is linear expansivity. You must know all this. Then using short method, you easily boycott certain areas because already you know how to make use of this. Our next class, we're going to, our revision class over these topics, because by the time we go through up to 3 more topics under it, we'll go back again. Do kind of revision and then move on. Because I know, even when it is 2 weeks to the JAMB exam, many people will come to lesson, will come and start lesson. 2 weeks, you see people coming as if magic will take place. Maybe hands will come, hey, 300. You say, amen. Amen, that's all. Go off my pico. So, those of you that started on time, that's good for you. Even the ones that started now, is still good because you sit up. I can clean everything, please. So, I believe all of us can define temperatures. Am I right? So define temperatures for me. 1 to go. Is a degree of what? Thank you. Hotness or coldness of a... What is the SI unit of temperature? Kelvin. Or where? Or what again? Or what again? The lower unit, I say SI. SI is Kelvin. But the lower unit is what? Degree Celsius. The unit, that's the unit of temperatures. Now, when you look at this word temperature, you discover that the instrument used in measuring this temperature is called what? It's called what? Thermometer. It's called thermometer. It's called thermometer. We have different thermometers. Even the infrared type. They are all thermometers. Now, these thermometers, I want us as JAM students to study, to look at those thermometers because they will ask you many questions. If you check your past questions, you see where from time to time they said, what is the thermometric substance, thermometric property, thermometric this? So the instrument for measuring temperature is what? Is thermometer. And we have up to 8 different thermometers. 8 different thermometers. Please, let us look at them one by one before we now come back to the scales. The first one, the first thermometer is called liquid in glass. It's called what? It's called what? Liquid in glass. That's the first one. Liquid in glass. Liquid in glass has 2. One contains alcohol. The other one is mercury. That's why you call it liquid in glass thermometer. It is just a simple thermometer like this. This is the ball. This is the scale. And the right here you have a uniform ball inside here. So this mercury or alcohol, whenever this is inserted in any particular temperature environment, it will start moving. The mercury or alcohol will start moving up, will start moving up. So this thermometer now has the bulb and scale and stem. The stem is where you read, but the bulb is the position that contains the mercury or alcohol. Now, whether it is mercury or alcohol, each of them is called thermometric substance. It's called what? Thermometric. So, what is the thermometric substance of liquid in glass? Mercury or what? Thank you. But this thermometer now has a property. Has a what? Called change in volume. Called what? Now, anytime you talk about liquid in glass, first thing that will come into your mind is change in volume. Change in what? Change in volume. Meaning that volume is the property of this particular thermometer. In any JAM question, just volume. Volume. Hence, you see liquid in glass. Volume is the property. Now, based on that, the condition for the calibration of this liquid in glass is that temperature, the condition is that temperature due to variation in volume is the same as temperature at the point of change, I want you to understand what I'm going to draw now. I have a thermometer already on the board. This thermometer, I want to find out the equation. If I want to prepare this thermometer newly without mercury or with alcohol, and it is not calibrated already. Maybe you are year one, you are asked to prepare. Those ones that will go into make engineering, they are normally asked to prepare a thermometer that will contain 360 degrees. Because those in make, they deal much with temperatures. But the ones in medical, they only make use of the thermometer. They don't know how it is calibrated. It's just, where is thermometer? They collect thermometer. If it's that of the one for human temperature, they will just collect the clinical thermometer, place somewhere here, place here, place anywhere, check without knowing how it is calibrated. But engineering, they are the ones that calibrate. So in their own area, we teach them how to do it. So here, this thermometer now, if I want to get the equation, that sometimes Jambo will give you an equation and ask you exactly the owner that this equation is used to derive which type of thermometer. Anytime you talk about volume, it is now temperature due to variation in volume is V at temperature, V at this temperature minus V at 0 over V at 100 minus V at 0 multiplied by 100 over 1. This formula now is the formula used for the calibration of volume thermometer. Volume what? I want you to write it down. Let me explain it. You can use it to solve any problem on volume thermometer, or you can still drop it and use normal scale in solving the same problem. But I want you to have an idea of this, that this particular thermometer is calibrated using this equation. So let us look at the parameters in the equation. The first one here is theta. Theta with a letter, small letter V. It is called temperature due to change in volume. Can you say it? Temperature due to change in volume. Or you say temperature at variation of volume. Now this is equivalent to, look at V theta. Look at V theta. We have V theta, we have V0. V0, this V theta is volume at change in temperature. But V0 is volume at ice point. V100 is volume at steam point. Because 0 is ice, 100 is steam. That's the rating. What is this? Temperature due to what? Thank you. But what is this? Volume due to change in temperature. Volume due to change in temperature. So whenever they ask you a question, this is the main one. This is the one you look for. Because they will give you V0, give you V100. And you look for this. So this is volume due to change in what? Temperature. Minus V0 is what? Volume at what? Ice. Ice point. Volume at ice point. Volume at ice point. And V100 is what? Volume at steam. 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 Steam point. Volume at steam point. These two are the same. So this is the normal equation of calibration. Then let's move up to the others, and at the end, I will now draw a sharp method of solving the problems. Even when you forget this, you can use those sharp methods. So let's move to the next one. Let's take these things one by one. Okay, let's first discuss the things that are involved here. Now, JAMB may ask you the differences between alcohol in thermometer and mercury in thermometer. We may look at the difference. And this difference is for advantages and disadvantages. For what? Yes. So let us look at alcohol and mercury. Can somebody give me one of the advantages of mercury over alcohol thermometer? Yes? Mercury does not wet glass. Mercury does not wet glass at all. Which means alcohol wet glass. That's why if mercury is here, if you use this to measure temperature as it is moving, anytime you take the reading, when it is coming back, everyone will turn back. For example, if you pour mercury inside a glass cup and you pour it away, all of them will go. All. No trace of mercury in that glass. But if you pour alcohol inside a glass and pour it away, even after 1 hour, if you touch that glass, you still see a trace of it, just like water. Because water wets glass. Water wet glass. The same thing with alcohol. So that's a good advantage. Mercury will give you the reading directly. Alcohol will still give you, but sometimes you need to color alcohol in order to see it reading. Because if you read it at its natural color, it will be difficult for you to read it. That's why you normally use color. And we say that alcohol is transparent. Is what? Transparent. Why mercury is what? Opaque to the eyes. It's opaque. So that's another great difference. Alcohol is transparent. For you to make use of alcohol in any thermometer, you add color, especially red color, to it. You add color to it so that it will be visible to the eye. Otherwise, as it is moving now, you may not even see it, see the point of its graduation, if color is not there. So that is one great advantage of mercury over alcohol. Then I want us now to look at the great advantage of alcohol over mercury. We just need few of them because I know you are good readers. You get through all this. And I will refer you at the end of this where you get more of these questions. Then give me one great advantage of alcohol over mercury. Alcohol has low freezing point, but that's not an advantage. Well, it's okay, but there is one you normally see from time to time in your JAMB. Somebody said something here. Alcohol is cheap. Thank you. Alcohol is cheap. Why mercury is what? Expensive. Yes. That's exactly why the thermometers containing mercury are more expensive than that of alcohol. Very, very. They're more expensive. Alcohol is very cheap. Obunu, an area is 5 before. I must be an area now. Alcohol bun kai now. Are we? It bought 5 before. I don't know Mauzi. So that's exactly. So these are differences between the two. Okay. Now, let us now look at other ones. Please take note of these things. They are very, very. By the time we start answering questions from the JAMB compile, you see that all these are important. Okay. So first one here is what's the first thermometer? Liquid in glass. Okay? Liquid in glass. That's the first one. Now, number two is gas thermometer. Gas thermometer. That's number two. It is good for us to discuss these things first. Gas thermometer. Gas thermometers. Those of you that are good readers contribute so much during lessons. And it's interesting. But those ones that will go home and press phone till night will never answer even a question. That's the problem. So let's look at the gas thermometer. Gas thermometer. I want to remind you that this is the most sensitive thermometer. Most what? Again. Most sensitive thermometer. Among all thermometers, that's the most sensitive. Why is it so sensitive? It is calibrated in millimeter mercury. Can you say it? Again. You know that anything graduated in millimeter is so sensitive that it can read very small difference. Very, very sensitive. Very, very sensitive. How does alcohol remain enclosed in a container? Alcohol remaining enclosed in a container. You know, it is not a steamer. It's a simple liquid. It's a very simple liquid. Okay, I will talk about that. I'll talk about that. Maybe you are referring to side of the chemistry. No. Alcohol is normally used to prepare something like this. Okay. So, remind me what I said about the gas thermometers. It's a very sensitive word. Very sensitive thermometer. Very sensitive thermometer. And why is it so sensitive? In millimeter what? Thank you. A millimeter mercury. Millimeter mercury. Anytime you talk about gas thermometer, you must remember a particular equation. When you want to use the thermometer when you want to use it as just a thermometer, you talk about number one, the substance. What is the thermometric substance inside it? What is the thermometric substance inside this thermometer? Thank you very much. Just use the word hydrogen gas or gas. It's okay. And what is the property of this thermometer? What is the property of this thermometer? Pressure. Thank you. Pressure. Thank you. So, okay, what is the property of the first one? Volume. The property of the second one? Pressure. Pressure. Thank you. This is pressure. So when you talk about the pressure, the same thing is represented here. That under pressure, theta due to pressure is pressure at theta minus pressure at 0 over pressure at 100 minus pressure at 0 times 100. This is anytime you have a calibration equation, it is normally drawn this way. Very, very important. This is for gas thermometer. This is for gas thermometer. And this is for volume thermometer or liquid in glass thermometer. So this will remind you that this is pressure. The thermometric property is pressure. The thermometric property of liquid in glass is volume. You must not forget this. You must not forget these informations. Okay. Now, I want to remind you again that whenever you talk about, anytime you talk about this, it is normally raised this way. Just look at the diagram on the board. It's normally raised this way. Huh? Okay, this one is better. This is normally the condition of the gas thermometer. And sometimes JAMB will just use it ordinarily to ask one particular question. For example, representing the level here as small h1 and the level from here down to the same curve as small h2. And normally, they ask you to determine the gas pressure, which is equal to atmospheric plus into small h2 minus small h1. This is another equation for the gas. This is another equation for the gas. Anytime they want you to calculate the pressure of that gas, this is the equation necessary for the mathematics. This equation. But the most important under temperature is this, which can be drawn into a normal line scale. So this is the second thermometer. The third thermometer, another, are you true? Second equation, big H is atmospheric pressure. Here is G, gas pressure here. Here is outside, the air coming from outside, which is big H, atmospheric. But this is the length. This is height of lower column. This is height of upper column. Height of lower column is small h1. Height of upper column is small h2. So, small h2 minus small h1 will give you the difference. That's why in your textbook or somewhere you see line like this and another line like this. They will give you a difference here as h. So this h now can be used directly. That gas pressure is equivalent to atmospheric plus the difference. This is the difference in height. That's the difference in height. Hey, some people are still confused. Hey, please keep that confusion by the side and move on. Are we ready now? Hey, we are ready. We are not ready. You're slow. Now, number 3 is thermocouple. Thermocouple. That's number 3. Thermocouple. That's another thermometer. Another important thermometer. Thermocouple. It is better for us to list all these thermometers, give certain information concerning them, and then move over to the scales and the equations and calculations. So next is thermocouple. Can I move on now? Please, oh, now the fast. Thermocouple. Thermocouple. Okay, let me use this advantage to represent a thermocouple. Thermocouple, we have eyes here. Eyes. We have boiling water here. Hot water. Hot water. So this one, we connected wire across this way to a galvanometer G. This wire A and B, different wires. This place we have ice, we call it melting point. Here we call it boiling point. So this is the thermometer known as thermocouple. This is the thermometer known as thermocouple. Thermocouple. We met all these things in our SS1 when we did temperatures, because these are in our various schools did it, except those schools without physics teachers, or the ones that employed agri teachers as physics teachers. That's the only. So, please, if you are with me, turn up. The first one is liquid in glass. Second one is gas thermometer. And third one is what? Thermocouple. So this is a thermocouple. What make up a thermocouple? 1, the ice. 2, hot water. 3, galvanometer, and then wire, different wires. So at these parallel joints, the temperature here and the temperature here, these two temperatures are converted by the galvanometer in reading to give you the EMF of melting point over EMF of boiling point. EMF of melting point over EMF of boiling point as equivalent to theta in degrees C over 100. So whenever you hear of the thermocouple, this is the equation for its calibration. We use it to solve problems on this. That capital letter stands for EMF. Stands for what? EMF. Yeah, small electromotive force. Electromotive force. EMF. Electromotive force. So EMF of melting point over EMF of boiling point is equivalent to the temperature in degrees C over 100. Where is this 100 from? 100 is from the calibration from 0 to 100 and make up a steam point. Make up a what? Thank you. So this is its calibration. Now we continue. Now a thermocouple is a sensitive type of thermometer, but it's not very sensitive like that of the gas. The substance is ice and hot water. Ice and what? But the property is EMF. Property is what? Thermometric property is electromotive force. Please put it down. The thermometric property of thermocouple is electromotive force. Electromotive force. Electromotive force. That's the property. That is the property. Electromotive force. We're trying to meet up, so let's continue. Number 4. Number 4 is resistance thermometer. Resistance thermometer. Or you call it platinum thermometer. Resistance, or you call it platinum thermometer. Platinum thermometer. P-L-A-T. So this is a resistance thermometer. Now let's talk about resistance thermometer. So this is a type of thermometer used in electrical gadgets. The thermometric substance is resistance wire, but the property is resistance. The property is resistance. Substance is resistance wire. Wire, the connecting program here. But here the game, which is the property. The property is resistance. Property is resistance. Property is resistance. Property is resistance. Meaning that this can be used easily as theta due to resistance equals resistance due to change in temperature minus resistance at 0 over R at 100 minus R at 0 times 100. So this is also the equation for resistance wire. Sorry, for resistance thermometer. Resistance thermometer. Resistance thermometer. Where do we see this kind of thermometer? Electric kettle and all that. You know, when you are heating, the temperature will be going. Hence, it is 100 degrees C. What will happen? It will off. Because that sensitivity is called what? What is that sensitivity in that kettle? What is it called? The sensitivity can they come here? Not the thermometer. The sensitivity. What's that sensitivity? Thermostat. Thank you. That's the sensitivity. Hence, so now the mark, bam, it will drop. And the water will start cooling. It will start cooling. That's why you cannot use it to boil rice, yam and other things, because hence it get to 100, it will off. Require Fire detector. It is placed into fire alarm. It's fire alarm that dictates. It's placed into fire alarm. It's a thermometer. It's not thermometer. It's anywhere in electrical gadget. It's placed into fire alarm, so that if there is any detection of fire, or if you touch open wire, bare wires, if you touch bare wires, occurs spark anywhere, it will sense it and start ringing. That there is fault somewhere. Our bank immediately, if we pay the doors, everybody will leave the banking hall so that they can trace the problem. Okay. So that's the resistor thermometer. Then number 5. Number 5 is thermo. Sorry, number 5 is, okay, some people cannot see here. Number 5 is which one do you use? We use okay, we let us go into the ones without equations, but they still have the property. They still have the property. They still have the property. So let us look at the other thermometers without equation of its calibrations. Let's look at them. We're already through with these ones with their mathematical values. So let's look at other ones, like number 5 is pyrometer. Pyrometer. Number 5 is pyrometer. 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 Have you heard of pyrometer before? Yes, thank you. Pyrometer is a type of thermometer used in bakery industries. Bakery. Oh, yeah, for example, you go to all those sensitive areas like Robin stores, this and all that, where they bake fast bread. Without this type of thermometer, they will not know that the product is done. In those days that were small, there was nothing like this. Here, German bread that you go down, but long shovel kageji, kuputia from the oven. I will check here. They may even, the bakers may not even be lucky. They will pick the ones that are not yet okay. They will feel okay, it's not yet done. By the time they know the whole thing, the back of the whole bread will turn to pomo. In those days, we are small. We normally go to Ataleo to get bread early morning. When you go there, you discover that the back of the bread, many of them are burnt. Because there was no thermometer then to tell them the product is done. You know that if you go to somewhere like ShopRite or Robin stores during their bakery, you discover that some of these things, when they are out, they will look white, kind of. But after some time, they change to tell you they are done already. Because it's not something you see by your, it's the thermometer that will tell them that it is done. Switch off. They'll switch off. It's the thermometer. So this type of thermometer, go with color. Go with what? So the thermometric property of pyrometer is color. Is what? Is color. Is color. Is color. The property is color. So the color, when the color change due to change in temperature, we give them exactly the information. That's why it is a thermometer. All thermometers, they do very inclusive and natural work. So it has no, JAMB don't normally ask of substance. It's just property. Property. So the property of thermometric property of a pyrometer is what? Is color. Is color. Now let's look at number 6. Clinical thermometer. Clinical thermometer. Clinical thermometer. Clinical thermometer. We all know about this one. It is used to measure what? Which temperature? The human body what? Temperature. Body temperature. That's the function of the clinical. Is to check the normal body temperature. And what is the range of the normal body temperature of a human being? 35 to what? So in your physics, it's 35 to 37 degrees C. But in medical, it's 37.4 degrees C. So we use that of physics for the exam. You run a hospital, a check here, or carrier 37.4. I say, I got bag for Munna. That you have some kind of fever. So above, normal is 35 to 37. And let me remind you, this clinical thermometer ranges from 35 to 45 degrees C. Please, can you hear me? The range of the entire clinical thermometer ended around 45 degrees C. And that's why most of the JAM questions, they would ask you, why is clinical thermometer? Why can it not be stirred in hot water? The reason why it cannot be placed in anything hot water. That's why JAM asks that kind of question from time to time. Who can answer that question? What's the reason why it cannot be stirred in hot water? Agabawa. Why Ogejibawa? The temperature is not up to what? 100 degrees C, thank you, is not up to 100. And for that reason, you cannot stir it in any hot water. Please take it down. These are important informations. You cannot stir clinical thermometer in hot water because the temperature range of it is not up to a steam point. It's not up to what? A steam point. It's not up to 100 degrees C, which is the steam point. That's why you cannot stir it. Probably may one burn hot water. It will just crack immediately. Gago. Okay. Now, clinical thermometer has what is called, there's a difference between clinical thermometer and other thermometers. If you check other past questions, you see this type of question. The difference between the clinical and other thermometers is that clinical thermometer has what is called key constriction. It has a constriction. It has a what? A constriction. It has a constriction. And no other thermometer operates such constriction. Let me use this diagram to show you what a constriction is. Normally, this is the normal thermometer. And everything will go through. But for the clinical, it will bend like this. And then make way for the mercury point. So this place is called constriction. Constriction. And what is the function of the constriction? The constriction will never allow the mercury to go back to the bulb after use until pressure is applied. If you have gone to any hospital or anywhere, you discover that after using, whenever they want to use clinical thermometer, they will add pressure to it up here. Why? Because they want the mercury to go back. The mercury will not go back. You know, you use it to measure human temperature, so it's important. After measuring the human temperature, it will still record the same thing. It will not go back until you're okay with the record. You will now add pressure to return it, maybe for another person's measurement. So it has constriction. That's the difference between the clinical and other thermometers. Constriction. Constriction. It has constriction. Okay. That is number 6. Number 7, minimum and maximum thermometers. Thermometers. Minimum and maximum thermometers. That's where I'll stop for this, for the reading of this. Minimum and maximum thermometers. Minimum and maximum thermometers. Minimum and maximum thermometers. Okay, please name these things for me. Number 1 is what? Number 2. Number 3. Number 4. Number 5. Number 6. And number 7. These are the ones we see right from 90s. That's the one we see in our JAMB past questions. So let's just stop. Let's just move on, change to the next level. So minimum and maximum means there are 2 different calibrations in one thermometer. Now let me talk about it briefly because of our time. This type of thermometer has the widest range of reading, wide range of reading of temperatures, the widest range of reading. Anytime you talk about wide range of temperatures, you talk about minimum and maximum. And why is it so? Because this particular thermometer is mounted on a material like wooden material. Please, I want us to look at this. I want us to look up here. This type of thermometer is mounted, is in this form. It's in this form. It has air here, air inside here, alcohol, mercury, alcohol. Now when you look at this, you discover I have air, alcohol, mercury, alcohol. That's the substance. Let's read the substance. Number 1 substance is what? Number 2, number 3, number 4. But in some of your question papers, they will remove air. And when they remove air, the answer will be what? Alcohol, mercury, alcohol. Are you with me? They will just remove air in most areas. They remove air and ask you to answer the question directly. In the year 2000 number 21. Go to the year 2000 number 21. I pleaded with the class, please. If you cannot buy any order, at least get something like this. There are other ones that are better than this one, but if they're more costly than this, at least get one. So somebody just showed me what I'm talking about now. Go to the year 2000 number 21 or pre-50 page 49. Page 49, question 5. Page 49, question 5. And look at the diagram. You know, learning is a process. Learning is a very serious process, please. Look at the diagram there. Okay, thank you. Somebody asked this question. Somebody took me back to number 6, clinical. You know, there was something I said, you cannot use the clinical without what? Without what? Without what? Huh? I showed you something here like this, okay? You can't use it without doing it like this. Adding that pressure. For it to go back to 35 degrees Celsius, to the normal base, for the mercury to return. But somebody said, if you fail to do that and you use it for another person's temperature, whether it will record that person's temperature, no. No. You must return it. Because it's going to act on the position where the mercury is and begin the next work. So that's why you cannot use it. Use the same for 2 persons at the same time. You use it, then allow it to return, use for the next person. And you discover that after using it, you clean. As long as you add pressure, you clean. Because you want to make use of it again for another person to avoid transfer of temperature change. We'll talk about that. Let's talk about this. Now, this is the last one I want to talk about. He said minimum and maximum. Somebody just gave us, somebody immediately opened somewhere. Maybe she saw this sometimes and showed it to me. The year 2000 number 21. Were you able to open your own? Now, give me the answer. Read the question for me. If you have your own together, 1 to go. The diagram above, yes? Shows a maximum and minimum thermometer, yes? The what? Divided into 3 portions, yes? P, Q, and what? From my diagram now, where is P? P is here. Where is the Q? Q. Where is R? So now, that's what they asked, divided into 3 portions. P, Q, and R. Then, continue. Which of the following, yes, is true about the contents? Contents, thank you. So what's the correct answer now? And A is what? Alcohol, mercury, alcohol. You know that they removed air. That's why I told you before that in such area, JAMB may decide to remove air because you can operate it without air. It's only during the operation that air is involved. Now, another question here. Where can this be located? Where can this thermometer be used? It can only be used in modern farms, agricultural farms. It's used in modern farms. All those places, all this, from overseas, like what? Like apple. Like apple. Because changing temperature, higher change in temperature will affect it. Lower change will affect it. So you need, when it will record higher, they will use irrigation machine to apply water there to cool the temperature. When it is too low, when the temperature there is low, they now open the electrical hot heater farms to supply heat, because this is a place that is maintained using different temperatures. That's why you have this. So it is used in a farm. On a big farms, sensitive farms, can you use here? Because this machine now, upper here is 0 degrees C. Lower here is 50 degrees C. Upper here is 50 degrees C. Lower here is 0 degrees C. So you see, you can't read. That's why it can read very wide temperatures. Very, very wide temperatures. Very, very wide temperatures. So a very sensitive one, Cobb. Thank you. So let's finally discuss the scales and stop. Is it time? Hey. You know, I started late. That was why. Okay, thank you. Okay, thank you. Let me not press you to the wall and add pressure as thermometers to you. No, that's okay. So I wanted to go to the final equations, derive it, and then stop. But hence, you people are already shouting on top. So let me seek permission. Okay, thank you. I don't know. You already, in fact, you asked me to stop, so let me stop. And now, listen to the short announcement before you go. Please, I think it's better to send, is it better to send the pages of the JAMB syllabus on just to your WhatsApp group or to leave it? So that you can, on your own, copy the topics. If you can print it, you copy. Okay, I'll give it to them. Thank you.